Hey there guys, this is AdamantLife, and this is episode 4 of Big Picture Python. And this is the tutorial series where we start out with the bigger picture, the wider scope of things, and then fill in the details as we go along. That way we can start programming and gaining experience programming while we learn. So, a couple things. We're going to kind of do a episode 3.5 to start out with, because there's a few things that I'd like to correct and add to our code before we move on to the next topic. Here, if you're reading the code carefully, you'll notice that we're just kind of creating objects here when we're creating our default values. But if we look here, this sword, shield, and backpack are still none because they never got reassigned. So we're going to go ahead really quick and fix that. Sword, shield, and backpack. And that will fix that. Now each of these things are a new instance of these classes. The next thing I want to do is, since we won't be touching backpack for a while, we'll probably do a little bit today, but just some improvements to backpack that can be made is we will add some more special functions. We'll be adding iter, which is short for iterate, so _iter self, and then return self.contents.iter. And what this does is it lets us iterate through the backpack as if it was a dictionary, exactly like we were doing with this other stuff where we're treating it like a dictionary. So what that means is down here, when we're iterating through for item and jimmy.backpack.contents, we can get rid of this .contents now. And furthermore, now that I'm looking at the code, we never actually needed these .contents when we're doing item assignment and getting and retrieval, because we had already set up backpack to handle those things. So now we can say, for item in backpack and do it that way. The next thing that we can do is contains. Contains is the other thing I wanted to do. So that is very simply _contains self item. And what this does is this checks if an item is already, or is in our backpack, or in our backpack.contents rather. So if down here we said, okay, so when we're talking about our item weights, if we were trying to check if an item is in our item weight sticks, we say if item in item weights. That's how we type it. If item in item weights, print item weights item as an example. That way we don't get a key error if we try to just plain print item weights item. That's an example of how it would be used. So this would evaluate to true or false the statement here. Again, an if statement followed by some evaluation. And if the item is in the dictionary, then we're good. So this would be, the string, candle, ration, and caltrops for the record. If we had candle, rations, and caltrops items, which is what we're going to be setting up today, unless those items had a special function to check the item weights list to get their string, to compare this with their string name, then that would evaluate false. That's kind of a for the record thing, because the object class instance is different from this string here, which I'm just bringing it up because it seems like something that maybe you might get confused with when we first start out. So, very simple. Just like everything else we've been doing with this class, self.contents.contains item. And we return that. So, this, just for the record, a lot of this stuff you could replace with the non-technical term. So you could say return item in self.contents, for example, here. I'm just using the long form of it for the heck of it. So that is all set up and good. Now we can just move on to today's lesson. So today's lesson, I said it was classes, and I kind of mentioned that it was subclasses, superclasses. So what those are, and as I've alluded to numerous times already, and you're probably getting sick of me saying it, is the item class we're going to introduce. So define init. So when we're starting with a class, we kind of want to take the base idea of that class and have that be our values, and then subclasses add things specific to the subclass. So for items so far we've had in our backpack we've had weights and quantities, names, weights, and quantities. The names were our keys, and then the quantities were our values, and we got their weights off of the item weights dictionary. We could just leave it, name and quantity for item, but it seems useful to have the weight as well in there. So self name quantity equals 0, and then we'll actually do weight as a method, I think. That way, in case something changes. I'll explain to that in a moment when I create that method. So self.name equals name, self.quantity equals quantity. Very straightforward. We've done this before. And then for weight, we're going to make this a method. The reason why is on the off chance that our item weights dictionary changes. So I'm just going to go ahead and do if self.name in item weights return item weights self.name, and then we'll go ahead and get the net weight of it, since that makes sense since we're including the quantity, times self.quantity. So now if we wanted to, down in our get weight function here for the backpack, we can instead say return some item dot weight for item in self, because we added this iterator in here, this iterator function. So now we can just iterate over self instead of self.contents, and then item dot weight will do the calculations for us itself. It will take the item weights and multiply it by its quantity. So that's an alternative we have. And the reason, again, we're doing this is in case this dictionary changes. We could, on creation, say, for example, weight equals 0, and then actually, we'll make this weight equals none. So if weight is equivalent to none, so if this evaluates true, and I'm just going over that explicitly because we haven't formally gone over if statements. If weight evaluates to none, and then we can do if self.name in item weights. I'll just copy this. Bam. And then this will be weight equals item weight self.name, and then self.weight equals weight. So this is what we would do if we wanted to have the weight be a constant thing. If we wanted the item weight to never change for any reason, the individual item weight to change as opposed to the net weight. And at that point, again, we would probably change this method to net weight, since this is different from the item weight. So there we go. We have item set up as a class. And next, we will go ahead and take sword and shield and backpack and turn them into items. So we're going to go ahead and keep name here because that's important. We kind of want to make sure that comes through. Otherwise, if it's any other keyword, we'll just collect it here and pass it on to item. And the way we subclass here, basically by putting item in here, within these parentheses, sword now inherits all of the stuff in here. including the initiate method. However, because sword may have different initiation functions than item, for example, it might have like self.damage or something like that. For that reason, we're going to overwrite the initiation function. And then in here, in order to call the init function from item, we're going to go ahead and use super. And we'll do it this way. Sometimes I like to do it a different way, which involves putting stuff in here. But to keep it simple, we're going to do this, and then name equals name. Again, I'm going to just go ahead, even though this is a positional argument, I'll go ahead and use this as a keyword argument just for clarity's sake. And then we use these double stars with our keyword. Again, this keyword here exists as its own reference right now. What these double stars mean is when we're passing to a function, when we're passing a dictionary to a function, if we use the double asterisk, it basically unpacks that dictionary and passes each of the key and value combinations in the dictionary as keyword arguments. So this will get expanded into quantity equals 0, and we're not actually using weight, so it should get expanded into quantity equals 0. The other thing that we can do is, because this sword, if this is like some kind of like standard equipment and we're expecting the character to always have a sword and his sword is just going to upgrade if it's that kind of like game or system or whatever, instead of having multiple swords that he can collect, then what we can do here is we can say kw quantity equals 1, because we don't expect this to ever be 0 or any other number. We can just set the quantity as 1. So whether or not the user or a different part of our program passes quantity to the sword constructor, for example, sword Excalibur, if he just does that alright and doesn't pass the quantity, then the quantity we're going to add as 1, which will overwrite this 0 here because that's only a default. Otherwise, if he tries saying, okay, I want 10 Excaliburs, it will also overwrite that. So it will look into the dictionary, grab the quantity key, and then set the quantity as equal to 1 right here. So he will only ever have 1 Excalibur. And that will set us up for that. Pretty simple. So I think what we're going to actually do, instead of right now changing both of these and the backpack to be items, what we're actually going to do is we're going to create one more class, and then we'll have a 3-tiered inheritance. And I'm going to call it equipment, and it will be a subclass of item. So I'm going to go ahead and delete this for right now, equipment. And I'm going to assume that equipment is stuff that are quantity 1. So define init. You are well familiar with this. Name, keywords. Just set this up the way we had it. And there we go. So now this is doing more or less what we were doing before. And again, this is just going to pass, instead of passing this information to item, now it's passing it to equipment, which is what super, the function, is useful for. Theoretically, we could have done item here, but now that we've introduced equipment, we'd have to go back through the code and fix this to make it be equipment. So instead, we just use super, and now we don't even have to worry about it. We just have to worry about what sword is inheriting from. And the one other thing, actually, that I wanted to add to equipment was a material. And I say that because down here, we have stuff like bronze, silver, leather backpack. So we will go ahead and do basic, because that's what we're using up top, I believe. Yeah, basic sword, basic shield, basic backpack as the default material. And then underneath the super, it doesn't actually matter whether you do it above or underneath at this point, but on the off chance that for some reason item had material itself, which it really shouldn't, like we shouldn't have material here if it's within the item class. But just to keep things in order, I like doing, the inheritance first and then the specific subclasses attributes. So self.material equals material. And that is good. All right, cool. So don't have to change anything there. Equipment. So to just go over as I'm copying this down, when we initiate a sword, the sword will pass its values, its name and keyword, to equipment. Equipment will take any values out of name and keywords that it needs, which are name, material, and keyword. And it will pass anything that item needs onto item, so name and keyword. So this material will not get passed on to item. And we come down here, equipment, and then super dot init name keyword. Add the keyword into here so that we can pass it stuff like quantity and material. And we can get rid of this self.name. And now our backpack, equipment, and shield are all equipment, which are a type of item. You will also notice, because I said that equipment inherits everything and item and sword inherits everything from the previous classes, that we can now do sword, shield, or backpack dot weight to get its net weight. But that also means that we're going to either have to, when we try to get its weight, check if it's none, or make sure that its value is in item weights ahead of time. So I'm going to go ahead and do that right now. So we'll do sword 2 pounds, shield equals 5 pounds, backpack equals 3 pounds. These are not realistic numbers. I am just adding numbers. So now we can get the weight of a sword, a weight of a shield, and a weight of a backpack. If we wanted to overwrite the equipment, overwrite in equipment, self, and then return a value based on the material as well, we could do that. And in which case, like I said, it's just overwriting the function here. So it would lose this function and have the new function named weight. So that is good. Anything else we wanted to do? Let's clear this out for now. We'll clear out all the printing stuff that we've done. We should also include length in here. This is our backpack dictionary. So it's sometimes useful to be able to get the length of something. Something without a length, an iterable without a length, generally is treated as false. So if we wanted to check if there were any items in the backpack, we could say if backpack, that's what this is going to let us do. If length backpack, rather. If length backpack, do something. So if length backpack is not equal to 0 is what that means, because 0 is the only way it's going to evaluate as true, or as false rather. Then you do something. And I will just type that out really quick in case you need it to see it. If not length, or if length backpack do something. So again, if, and then this evaluates to either 0 or a number greater than 0, because it's going to get the length. So if it is 0, then this will be a false statement because 0 evaluates as false. Otherwise, this will be a true statement. So if the length is greater than 0, this is going to be true, and then we do something. Otherwise, if the length is 0, then it does false. And again, you should see this coming already. Self.contents underscore length, just to continue with the way we've been doing these things. Again, to reiterate, this is no different, I don't believe, than return length self.contents. But we're going to be more explicit. And I think that may be everything that we wanted to do today. Is there anything else we want to do? Oh, actually, there is something else we want to do. One more special method. And I'll put it underneath equipment. So define REPR self. REPR, short for representation. So this is what it's going to show when we, like, for example, print it out or put it into a string. So if you've run this before and you've tried printing an object instance, Jimmy.backpack, let me just, I'll comment this out really quick so that we can run this. Okay, I just realized we missed the parentheses here. Hopefully you're following along. Did I miss them down here on backpack? No, I didn't. Okay. So we run that and we get main.backpack. I'll explain scopes and what exactly that means at a different point. Backpacked object at hex code location. So instead, once we supply this representation thing, and the way I'm going to do this is by using format on a string. I'll change these to double quotes. I don't know if I explained the difference between single and double quotes, and the answer is that there is no difference. Single and double quotes in Python are interchangeable. So I normally just do single quotes for the heck of it because I don't have to hold down the shift button. But one thing you can do that is convenient is you can put double quotes inside of single quotes and it will still be a string. So if I wanted to say hi, Jimmy, and there should be a comment in there, say hi, Jimmy, then that works. Whereas if I tried to do this with double quotes all across, you can see that this hi gets trapped outside of these double quotes, so this becomes a string, and then this becomes a string. So these single quotes let us do it like that. Otherwise, the other way we can get around this is to escape the characters. This is one of those string things that you would learn if we were going over the itty-gritty with strings. A backslash will escape special characters in Python, and most languages actually. So that's the other way that we can include double quotes within a string. Like I said, my default is just to use single quotes. We'll use double quotes for now. Now, format. This format method that strings have. What that means is anywhere there are a set of curly brackets, it will replace those curly brackets with something else. That's the most basic usage of it, and the one that you use most often. There are 3 ways to use the format, and that is positional arguments, keyword arguments, and then index arguments. So you already know what positional arguments are. That means that if I say, self.material, or maybe self.name, self.material. No, let's do 3. 3 will make it easier. So we're going to have self.name, self.material, and self. Okay, so really quick, this is going to be another special function that we don't actually have to include. This comes stock with any class that you create, and that is self.class. So this instance is class. So if it's an equipment, it's going to be an instance of equipment. So it will pass us this class, and then the class has a attribute called name. And that is simply the string representation of the class's name. So by doing this on equipment, this gets evaluated to the string equipment. And the reason I'm using this is because equipment gets inherited. So when sword inherits this representation function, instead of using equipment here, it will use sword instead. So right now we're getting, for example, print sword Excalibur. This would then print Excalibur, because that's its name. Its material right now is basic because we didn't supply it, right? Because material has a default value. So Excalibur, basic, and then sword, because sword is its class name. If this was a shield, then it would be Excalibur, basic, shield. So Excalibur sheath, I'll say, for the heck of it. So that's how that works, how that resolves, and that's how positional arguments work in format. So you just match up first, second, third curly brackets with first, second, third argument. Indexes work similarly. So if this was 0, 0, 1, that would be 0 index here, 0 index here, and then first index here. So that would actually be Excalibur, Excalibur, basic. Really simple again. You just get the index of the positional argument in the format, and you're good. The third way, which is the most explicit way, and the way I prefer at any rate, is to make them keyword arguments, like I said. So, class name. So now we can just say name equals, and I will drop these down onto individual lines. As a general coding rule, you kind of want to keep stuff as far left as you can afford it, in case somebody's working on like half a monitor, or they have a smaller monitor. That way it's not trailing off the edge of the screen. So there we go. So now, just like a class, it's going to plug in, or a function. You can use keyword arguments, in case I haven't said that before, with functions. Yeah, I don't think I've said that before. So functions can take keyword arguments. So now each of these keywords go into material name, class name. And down here, I'm going to go ahead and just add print Jimmy dot sword print Jimmy dot shield. So now, instead of getting main backpacked object at hex code, main sword object at hex code, main shield object at hex code, we're going to get something that looks reasonable. Okay. I missed my double underscore there. So this should work now. There we go. Basic backpack, basic backpack. Why are these printing twice? Oh, that's why these are printing twice. Let's go ahead and change this. So instead of just having, bronze sword, let's update this. So Worm Slayer as its name, material is bronze. R is Magnola, material silver, and bag of holding. Holding material equals leather. Another quick fix to our code. Because we changed the length function on backpack, the Boolean value of the backpack is now none when it's empty. So we're just going to go ahead and change this to be more explicit, all of this, just in case something like that happens again. So equals none. And equals none. We run through. There we go. Bag of Holding is a leather backpack. Worm Slayer is a bronze sword. Arx Magnola is a silver shield. And that one was a bit bumpy. I apologize, but we have gotten through. And we can also come down here and do this really quick. Item. Thank you for watching. Like, favorite, subscribe, comment, please. All of it appreciated. Next episode, I'm not entirely sure what we'll do, so that's going to be a surprise. We'll see what I figure out. Until then, have a wonderful day, afternoon, or evening, wherever you're at in the world, and I'll catch you later.